Algebra 2, we're looking at lesson 5.5 and more factoring trinomials with the lead coefficient greater than 1. Look at our first learning target. I can solve a quadratic equation with lead coefficient greater than 1. Guys, whenever you solve a quadratic equation, what you need to do is have 0 on one side. I see that there's just this one term of 7w over here. I'm going to minus a 7w from the left side. I'm going to minus a 7w from the right side as well. None of the terms on the right are like terms, so we're going to have, plain and simply, a 2w squared minus 7w minus 4. Now, what should catch our eye is that the lead coefficient is not a 1. It's actually a 2. So when we factor here, what we do is, this is called the AC method. AC method in that the general form of a quadratic equation is ax squared plus bx plus c equals 0. We always multiply a and c when our a is not a 1. And by the way, just to be super clear here too, I know sometimes kids are bothered that everything's here on the right side. If that's troubling you, please understand that you could very quickly just switch, rewrite this equation with 2w squared minus 7w minus 4 on the left side, set that equal to 0. So what happens is we're going to make our little wheel, and we're going to multiply 2 times negative 4. 2 times negative 4 is going to get you negative 8. And then what we're adding up to, of course, is going to be negative 7w. Now, we begin to search and find ways that we can multiply to 8. There are not a lot of ways that's going to happen. You could have a 1 and an 8. 1 times 8 is 8. You could have a 2 and a 4. 2 times 4 is 8. If I'm multiplying to a negative 8, one of those numbers, one of the two numbers must be a negative. But when I'm adding to a negative 7, guys, that means that my larger number, of course, is going to have to be the negative. The negative sign is going to really come from, in the addition, from having more negatives than positive. The bigger number always controls the sign. So when you're adding to something negative, the big number of your 2 have to be the negative. Now, you can very quickly confirm that 1 plus negative 8 is negative 7. It would only take you a moment if you need to do that, and it's definitely okay to see that. You know that 2 plus negative 4 won't do the trick. So I'm going to have this as a 1w and a negative 8w. And now that we've found the right combination, this method that we're working with is also known as splitting the middle term. I'm going to say that I have a positive, my plus 1w right here. I'll have my minus 8w over for that second pairing. So you always split that middle. And then, like we've been doing, we look at our first 2 terms to see what we can factor out. And then we're going to look at our last 2 terms and see what we can factor out from them. And as you look at your first 2 terms, I hope it's pretty clear that you might not be able to divide anything out other than a 1, but you can divide out a w. And that will leave you with 2w plus 1. In fact, I'm going to move this down just a little bit just so you can see what's really happening here. It's like we're dividing both of these by w's. Now, in the green factoring, like we've been saying, if you know what you're doing, if you've done your first part correct, you know that you have to have an identical parenthesis. You have to have a 2w plus 1 over here. You begin to say, what can I divide out from a negative 8 and a negative 4? By the way, you're going to have to pull a negative out because you're starting with a negative. And I hope we'd agree that you can really divide out a negative 4 from both of these. Negative 4 divided by negative 4, that's where we get our 1. Negative 8 divided by negative 4, that's where we get our 2. And, this is review at this point. This is what we were doing last week. But look, whenever we've got those two parentheses being the same, it's like that can come out in front. Here's your 2w plus 1. What's left? Well, imagine that this is gone. You've got your w minus 4. Set that equal to 0. And then we're going to take 2w plus 1. Set that equal to 0. Guys, when we were solving, we'd always set our parentheses equal to 0 and solve. Here I'm going to minus a 1 from both sides and divide by a 2, and I'll have w is equal to negative 1/2. Over here I'm going to add a 4 to both sides, and we'll have w is equal to a 4. Here you have it, your two answers. Let's real quickly take a look at number 2. Number 2 is very, very different. We're looking at a problem where it says, write a quadratic equation. In other words, write something like this 2w squared minus 7w minus 4. So we're actually going to go backwards. The irony is you're going to see solutions like w equals 4, w equals negative 1/2. They're going to tell you what roots are. So they're telling you, in this case, the roots, the final answers to an equation would be x equals 2, x equals 3, and our lead coefficient is a 4. Look, here's a little trick, guys. Whenever you have x equals this number, minus, get rid of this to get 0 on one side. Subtract a 3 over here, you'd get x minus 3 is equal to 0. Why? Because these are going to be your parentheses. You're going to have x minus 2 times x minus 3. But we have a lead coefficient of 4. That means put your 4 out in front. We're going to distribute a 4 to that later. So definitely solve. Get your x equals those numbers. Get 0 on the other side. You're going to see these are your parentheses. Now what? Well, our focus will be first dealing with the two parentheses together. We're going to have to really FOIL that. We're going to distribute and multiply through. So as we do that, let's just do x times x. You get x squared. X times minus 3, you get a minus 3x. Negative 2 times x, you get a minus 2x. Negative 2 times negative 3, that will get you a plus 6. Now what? Well, from here we can combine our like terms. And negative 3x minus 2x will get you minus 5x. And we have one last step, and that's to distribute your 4 to both. And you'll have 4x squared minus 20x. And 4 times 6 is 24. This is what you're going to type in on the left-hand side. Alex will have it set up always equaling 0. The last type of problem that we're going to take a look at today is really a quadratic equation word problem. And we're going to have a rectangle. We're going to have this rectangle right here. And it says the length of this rectangle is 3 more than, well, this means we're going to add. So we're going to go 3 plus. Double is always 2 times. And the width is just described here. So I'm going to let the width be called x. You could call that right here. But what about the length? This long part of the rectangle is going to be 3 added to, 3 more than, or 3 plus, and then we'll have 2 times the width. That's 2x. So 3 plus 2x. Or, if you'd like to, addition, the order doesn't matter. You can change that to 2x plus 3. So either 3 plus 2x or 2x plus 3. The area, length times width, is 35. So let's go ahead and do that. Area, of course, is length times width. So I'll go 2x plus 3 times x. And I'm going to set that equal to 35. It's base times height or length times width. And if we distribute real quickly, we'll have 2x squared plus 3x equals 35. Now at this point, our problem really is the same thing as number 1. If I minus a 35 on both sides, you might wonder why we're doing that. We're going to have to get our equation equal to 0. And then tell you what, our AC method, I'm going to make myself a little wheel here and say that we're going to multiply to A times C. What's 2 times negative 35? Well, it would only take you a moment to see that should get you negative 70. What should we be adding up to? Well, the middle, 3x. Then what? We start going through a process of trying to find how we can multiply to a 70. You can have 1 and 70. You could have 2 and 35. We could try a 3. Does 3 go in? Well, no, you could confirm that with a calculator. Does 4 divide into 70? Well, you could always check. You're going to see it doesn't. You don't get a whole number when you try to divide that. How about 5? I think that's going to work, isn't it? 70 ends in a 0. 5 and 14. You can think, would a 6 work? Well, no. But a 7 does. 70 divided by 7, of course, is a 10. And 8 won't go into 70, neither will 9, and then you're back at 10. So here are your possibilities. You know if you're multiplying to a negative, one of your numbers here have to be a negative, the other will have to be a positive. If you're adding to a plus, that means the bigger numbers have to be the positives. That means my smaller numbers have to be the negatives. And I hope it's pretty clear that to add to a 3x, it's only going to take you a little while to find that it's going to be the negative 7 and the 10. Negative 7 plus 10 is positive 3. So let's break the 3 into a minus 7x and a 10x, and then go ahead and factor. So how do we factor by grouping? Well, we look at our first 2 terms here, see what we can take out. We're going to look at our last 2 terms over here, see what we can take out. And the first 2 terms, remember, you could always take out an x. You'd have 2x minus 7. Right now, you should know you'd have a 2x minus 7 remaining. And my goodness, as you're looking here, what can be divided out from a 10 and a 35? By the way, you're getting a huge hint from the parentheses here. I hope you can see that 5 divides into both. And there you have it. What do we do next? Well, we're going to have to look at our 2 common blue parentheses here. That's your 2x minus 7. Pull that out. Have your x plus 5 remaining. Then what? Go 2x minus 7 equals 0. X plus 5 equals 0. Here I'll add a 7. And then I'll divide by a 2. And I'll get 7 over 2, which is 3.5. When I subtract a 5 over here, I'll get x equals negative 5. But guys, a side length, a width, cannot be negative. You're only going to have this answer of 7 over 2, or you could type it in as 3.5.